Hi everyone, welcome back to my next session. Now I'll be sharing my screen. I'll be putting that in a slideshow mode. So in the last lecture, we discussed about what is multi-biometrics. I mean, the multi-biometrics means that will be coming from the multiple, I'll be collecting the multiple inputs from the single user. And then the advantage of the multi-biometrics is, in case if one input is not functioning properly, we can manage with the another input that we collected during the enrollment process. And second, we discussed about the disadvantages. So if you are using a multi-biometrics, that is only preferred for the large scale industries. Now it is not preferred for the small scale industries because it will be more expensive. So then we discussed about the four modes of the operation. Okay, just I given the introduction about the four modes. Sorry, we discussed what is the four modes of the operations. In that, we discussed deep about information sources and the mode of the operation. The first design function is the information source. In that, we discussed about what is information source means. There will be multiple traits will be there and we'll be taking any two or three traits for our biometric system. Then modes of the operation, there are serial mode and the parallel mode. Always the serial mode is preferred. The reason is that after taking out the finger, if the additional feature is needed, we can add it. Okay, after taking the face and finger, if the additional feature is needed, we can add it. But in case if it is a parallel, all the inputs we have to collect initially itself, as well as while giving the input. I mean, while I'm how we can say is that while we are marking our identity, all will be parallelly. I mean, biometric system will be capturing everything parallelly. So it will be very difficult for the biometric application that they used in the organization. So sometimes biometric application may get confused. So only it's better to use the serial mode of the operation. First, I can place my ID and then I can show the finger. So it can be operated in a sequential order. So this is the reason why the serial mode of the operation will be preferred over the parallel. Okay, now in this video, we are going to discuss about the level of the fusion and fusion approach. And before that, in the previous lecture, we discussed about multiple sensor. In multiple sensor, we discussed about optical and the capacitance. In multiple algorithm, we discussed about texture level as well as the minutiae algorithm. In multiple instance, I'll be collecting the input from the left eye as well as the right eye. Multiple samples means I'll be collecting the samples from my same finger. And multi-model means I'll be collecting the inputs from the multiple traits. So until this we discussed in my last lecture. Now we are going to discuss about the levels of the operation. First will be the raw data. I'll be collecting the input and then the feature extraction will be made by using the minutiae algorithm. So I already said multiple algorithm will be preferred. In that the best algorithm will be the minutiae algorithm. Then I have to identify whether the score is matching or not. Okay, if it is matching, then it will be mentioned as the decision. It is coming from the genuine user. So automatically the score will be the similarity score. So in case if it is coming from the different user, I mean, if the samples are collected from the different individuals, so automatically the score will be dissimilarity and we have to give an output as it is coming from the different individuals. So the resultant will be imposter. And in case if the score is similarity and we can give an output as the score is coming from the genuine user, so it is matching. So like this, we have to show the difference while you are highlighting in the output region. Now we can move into the biometric fusion. There are two things are there, prior to matching, after matching. So sensor level and feature level that will be coming to the prior to matching. And after matching will be coming under score level, rank level and the decision level. Now I'll be starting with sensor and the feature level. So in sensor level, I'll be collecting the multiple samples from the same individuals but multiple samples are collected from the same individuals. So I mean, sorry, for example, I collected the multiple inputs and then I have to join it. And while joining it, I have to do the alignment because I collected the multiple inputs from the same user at the different period of the time. So while I'm keeping the sensor, I might have kept at a different place. So alignment should be made. After making the alignment, and then I have to find it out the region of the interest and how the region of the interest that will be done by using the image segmentation. What is image segmentation? Which is exactly needed, only that will be taken and remaining thing will be discarded. Which exactly be taken as an input, ROI equal to 1. That will be represented as a true. ROI equal to 0 will be represented as false. That particular region will be discarded. Then only the minuity algorithm will be applied. And then what you have to do is that according to that, the score will be predicted and then the matching will be done. Now we will be moving into the feature-based extraction. If you take the feature extraction, after collecting the two samples, immediately we have to make a minuity algorithm. That's the difference. But here, after joining it, after applying the region of the interest only, we are applying the minuity algorithm. But here, after applying the samples, I mean, after collecting the multiple samples, immediately we have to apply the minuity algorithm. After applying the minuity algorithm only, after doing the alignment, after applying the minuity algorithm, then we have to do the alignment process. But in sensor level, before applying the minuity algorithm itself, we have to do the alignment process. So this is the difference. So then we have to identify the score and then we have to make the decision. So this is the difference between the sensor as well as the feature level extraction. Now, we'll be discussing about the PCA as well as the LDA algorithm. So I already discussed about prior to matching in my previous lectures as well. Now we discussed very clearly with the diagrams. So in my next lecture, what we can do is that we can discuss about the PCA problem in deep, because it will be taking 15 minutes again. So if you start freshly, you can understand very clearly about the PCA problems. What is the main objective of the PCA is that there will be a multiple rows will be given. What you have to do is that we have to convert that into a single row. I mean, the length of the data set that will be reduced. So it will be easy for the users to process with the data set. So that's the reason why we are going to use with the PCA. In the next lecture, we can discuss deep with the PCA concepts. So as of now, in this video, we discussed about the fusion strategies as well as the levels of the fusion. What are the various levels of the fusion are there? First, the raw data, and then the feature extraction will be there, and the score will be predicted, and score can be divided into two types. One will be the similarity and dissimilarity. Accordingly, the decision will be made. And then we discussed about only the prior to matching. Prior to matching, we'll discuss about the sensor level and the feature level extraction. In the next lecture, we discussed about what is a PCA. Okay, now I'll be stop sharing it. Thank you.